Good morning. Bella, Isabella, Avery, Gabby Company, Annie, and Kaylee B. Oh goodness, who did I just let in? Kaylee B. Let's see, Carter, Christmas Carter, Lily, Aaliyah, and Kyle, Ethan Lamont. Allie is here. Stop it. Yes. Guys, this is a party today. I love it. Okay. Ethan is here. Perfect. So we are missing quite a few people still. What can you guys hear me? Jello. Let me know in the chat. Okay, perfect. You guys can hear me. Wonderful. I was just having a lot of problems last period with my hearing abilities, people being able to hear me. So I'm gonna get started because I'm gonna get you guys out of here early today. Yes, I know, right? So Carter, let me see if I can figure this out. So I'm using my microphone that should be able to. Oh, okay, okay, never mind. Thank you, Carter. So we're missing quite a few people though. Alyssa Button, Sawyer, Courtney, Jonah, Brando, Faith, Jaden. Oh my goodness, we're missing a bunch of people today. Hopefully they can join us. Oh, somebody left. Oh no, we lost somebody. Okay, whatever. It's okay. Let's open up the assignment for today. It is the slideshow 1/04 task at school. It looks like this. One-step equation review. What's up, Diego?
What does CFR mean? Like, I see it on the title.
Oh, check for, oh gosh. Oh gosh. Retention from last. So this is stuff that you guys learned last year and maybe in 6th grade. So this is just sort of before we get into unit 4, we're doing a week of review from stuff from last year in 6th grade. Okay. Ooh, Jane Ramos is here. Yay! Fantastic. So yeah, the CFR doesn't really mean anything for you. It's telling you that it's before it's before we start unit 4. Okay, good question there, Diego. Wonderful. Let me pull up the chit chat so I can sort of see that because I love to be able to see you guys. Let me just do that. Perfect. And let's take a look at our learning targets for today. So learning targets are on slide number 2. Okay, and I can solve an equation with one step to isolate the variable. That's okay, Jane, not a big deal. Isolate my variable. So 2 words that might be a little bit tricky. What does the word isolate mean? Let me know in the chat, or you can unmute and let me know. What does it mean to be isolated? What does it mean to isolate something? Yes, very good, Jaden. Put it by itself, it's it's alone. Carter said it's COVID basically. So if you were to stay in my room all day, perfect. Yes, exactly. It's if you're alone, right? It's when you're all alone. We're trying to get the isolate or get the variable all alone. And when we talk about a variable, another word that we use when we're talking about that word variable is when we're talking about a letter, right? When we use a lot of X's or Y's or maybe even the letter A. We need to isolate or get that variable, that letter, all by itself. That's step number 1. Okay, and then we're going to be able to check our answer to make sure that it's correct. Okay, so we're going to skip over slide number 3. We're going to go right into slide number 4. Okay, so our task for today on slide number 4 is we're talking about solving one-step equations. And one-step equations are ones where you need to use the inverse or opposite operation to get the variable by itself. So we're going to have, so maybe it's x plus 2 is equal to 5. We need to get that variable or that letter all by itself by doing the inverse or opposite operation. Then the second step is we need to check your answer. Okay, so we're doing 2 steps today. First, we're using the inverse to get the letter by itself, and then we're going to plug it back in and check our answer. Okay, and let's talk about what inverses mean. What does it mean to be an inverse? Inverse operations undo each other. And we know this because we've sort of been talking about this since, oh gosh, when did we talk about? We introduced the idea of inverses in, I would say probably 3rd grade, but we don't necessarily use the word inverse, but we talk about the concept of inverses all the way since 3rd grade. Inverse operations sort of undo one of each other. It's the opposite operation. So when we do the inverse operation, the inverse of addition is subtraction. Addition is canceled out by subtraction. Subtraction is canceled out by addition. They go hand in hand, right? Nice job. Thanks for joining us again. Sorry you got kicked out, buddy. So when you have subtraction and you want to cancel it out, the inverse of that is addition. And then the same thing with multiplication and division. Multiplication is canceled out by division, and division is canceled out by multiplication. Okay, so these are some things that we've definitely been using since probably 3rd grade. Or even if we didn't call it an inverse, we've been talking about this idea of opposite operations since about 3rd grade. We also talked about like the inverse of addition and subtraction probably since 2nd grade. So let's take a look at slide number 5. Okay, so when you're solving an equation, you have a goal. When you're solving an equation, the goal is to get the variable or the letter by itself. A one-step equation means that there is only one step that that needs to be done to solve for the variable. So we might have to add to get rid of that, to isolate that variable. We might have to divide, we might have to multiply, we might have to subtract, but in a one step, there's only one thing that you need to do to get that x or that letter by itself. Okay, so to get the variable by itself, you need to use the inverse or opposite operation. Okay, it's always a good idea to check your answer when possible. I'll show you how to put your answer in to make sure that it's correct. So this equation actually was like right here when on your slideshow. So you might want to act this equation and throw it up right here so that you can see this whole sentence right here. Okay, nice job. So very good, Jaden. Jaden's ahead of the game here. In the equation above, 2 has to be added to x. 2 is being added to our x. How do we undo this addition here? What operation are we going to have to do here to undo this plus 2 on the left side here? We have to think about what's the opposite of plus 2. What are we going to have to do to each side? Let me know in the chat box here. Nice job. Not exactly, Carter. Well, yes, but we want to keep the x by itself though. So we want to do something to get the x by itself. We're not going to move that x, but good idea, Carter. Nice job, Billy. Nice job, Bridget. Nice job, Avery. Nice job, Jaden. It was very specific. Nice job. So all my friends that said subtraction, and maybe my friends that did some other things, how much are we going to either add or subtract? Or actually, everybody said subtract. So how much are we going to subtract? We want to be specific. Good. So when I'm looking at this equation here, we're going to subtract SUB. And when we look at this equation, we're going to say x plus 2 is equal to 7. And we need to subtract 2 from both sides. So when we subtract 2 from the left side here, we have to do the same thing to the right side here. So we'd have to subtract 2 from the right side. So when we do that, it cancels out this plus 2 gets canceled out by this minus 2, and we're left with just our x on the left side. Let me just make this a little bit bigger. Sorry, guys. Okay, so we're left with just our x is equal to, what's 7 minus 2? Nice job, Bridget. Nice job, Lily. What does that equal? Nice job, Jaden. Nice job, Bridget. It's equal to 5. Awesome, awesome, awesome job. So now look at that. We were just able to do a one-step equation. So when you have add 2, we're going to have to subtract 2 from each side. Or if it's add 7, we're going to have to subtract 7 from each side. So whatever you're doing with that number here, you're going to do the opposite operation, and then you're going to do that same number. So it's minus 2, minus 7 if it was plus 7. Very good. Nice job. So now let's check our work. Let's see what the experts had to say when they did this problem. Mostly me. Okay, so step 1, if we think back to the 2 steps that we need to do when we're solving a one-step equation, step number 1 was use the inverse operation to get the variable by itself. To undo adding 2, you need to subtract 2. Ah, look at that, guys, we got it right. So to undo this add 2 to both sides, we have to subtract 2. And we're left with, see how this subtracting 2 cancels this whole piece out. And we're left with just our x is equal to 7 minus 2 equals 5. Oh my goodness. The minus 2 cancels out the plus 2 because addition is canceled out by subtraction. Oh my goodness, this is crazy stuff, guys. So then step number 2 is we need to check our work. So that means I need to plug in 5 in the original equation to make sure that that's actually equal. So if I take my equation of x plus 2 is equal to, oh, no, wrong button. X plus 2 is equal to 7. And we said that x is equal to 5. So now I can take that x out and I can write the number 5. And then I can add my 2 is equal to 7. Is 5 plus 2 equal 7? 5 plus 2, 5, 6, 7. So 7 is equal to 7. Yes, very good. Nice job, Jaden and Bridget. Very good. Let's see what Avery said. So we do the opposite, like do subtraction if it's addition. Very good. Nice job. Exactly, Avery. Very good. When you have a one-step equation like this, exactly. It's exactly like Avery said. You do the opposite operation to get that canceled out. So when we plug it in and we solve it, if both sides are equal to one another, we are rock stars and we did it correctly. Very good job. Nice job, guys. I'm going to do green because that means green means good. Go. Woohoo! We did it. Woohoo! So now we can also think about equations as scales. This I know that you guys did last year when we were in 7th grade because Miss Lupa, I know you guys didn't have Miss Lupa, but Miss Lupa was a teacher with me last year, and she's like, they're definitely gonna do this. So yes, I know you guys were able to do this piece at least last year, where we were thinking about equations as scales. So when you're solving an equation, you can think of it as a balanced scale, right? So we have our balanced scale right here. Think of the equal sign as the balance point in the middle of the scale. So when you're looking at an equation here, it's not necessarily like the physical center is going to be this piece right here. It's the equal sign is going to be the centerpiece of this. So whatever on either side is going to be weighing the same amount. So the weight on the left side and the right side of the scale have to be the same. So we say x plus 2 is equal to 7. And if we think about how are we going to find out what that x value is worth, let's take a look at what we would do to our scale to figure out what that x value is worth. So we said plus 2 here. So if we were looking at this scale to get the x by itself, visually representing by itself, we would subtract the 2 dots from the right side here, the left side here. Whatever we do to the left side, we have to do to the right side. So we would have to take 2 dots away on the right side as well. And so that x is going to be equal to how many dots? 5 dots. if you're doing anything to an equation, it is important that you do it to both sides. Give me 1 second, Avery. So that it stays balanced. You can't change the weight on one side without changing the other side by the same amount. So in this case, we took 2 away from each side. So we took 2 of the little dots off each side to get that x by itself. Make sure you do the same thing to both sides of your equation. So 5 is my answer. Subtract 2. Very good. That's exactly right there, Avery. For that picture, that's exactly right. Very good. Nice job. Awesome. So now let's take a look at a different example that we're going to take a look at for today. Equations with subtraction. So now let's try another equation, but this time it has some subtraction in it. We have x minus 3 is equal to 6. What I want you to do is I want you to think about what is that opposite operation? What are we going to do to both sides of this equation to get that x by itself? Let me know in the chat specific. If you're going to say add, tell me what number. If you're going to say subtract, tell me what number. If you're going to say divide, tell me what number. Nice job, Avery. Very good, Jaden. Nice job, Gabby Campany. I'm going to give people another 2 seconds to give me some answers in the chat. I want to see what people are thinking. How are we going to get that? Oh, give me 1 second, Diego. Awesome. Diego, what were you thinking, my friend? You can unmute and let us know.
No, I wasn't thinking anything. It's just that I tried to tap the chat and I raised my hand on accident.
Oh, okay. So when we're thinking about this, we have a minus 3 here. So we're not going to be doing multiplication or division because we have a minus 3. And the opposite of minus 3 is adding 3. So we're going to have to add 3 to both sides. So in this box right here, we should say add 3 to both sides. Okay, so that is how we're going to maintain our equity, get our x by itself. We're not going to multiply by 2. The 2 is not a number anymore. We're not doing 2 every single time. We need to look at the equation itself and see what number, what's going on here. So we have our x, and then we're subtracting 3 from it. To get that x by itself, we need to add 3 to each side. Very good. Let's take a look at how it's on slide number 10. Okay. So on slide number 10, we have the equation here. And it says step number 1 is we need to use the inverse operation to get the variable by itself. To undo subtracting 3, we need to add 3. Make sure to add 3 to both sides of the equation. We add 3 to both sides so that we maintain our equity. Okay, so if we look down here, plus the plus 3 cancels out the minus 3. So we add 3 to the left side to cancel this guy out. Then we have to add 3 to the right side as well. 6 plus 3 gets me 9. 9 is equal to what's left on the left side, the letter x. Okay, and when we do that, we have to plug in 9 for x in the original equation. Does 9 minus 3 equal 6? What do we think? Does 9 minus 3 equal 6, guys? Nice job, Jaden Ramos. Nice job, Campany. Nice job, Avery, Bridget, Lily. Fantastic. I love that people are giving me answers today. You guys are super active in the chat. I love it. Keep it up, guys. Yes, look at that. When we do 9 minus 3, does it equal 6? Yes, that answer is correct. 9 minus 3 does equal 6. Oh my goodness. Nice job. Okay, so now we're throwing it around. We're going a little bit differently. Now we're dealing with equations that have multiplication. Equations with multiplication. Okay, multiplication and division are inverses. You can use one to undo the other. If the equations involved multiplication, you'll need to use division to get the variable by itself. So if you have, for example, 3 x is equal to, I know, why am I saying 3x? 17x is equal to 5. You undo that multiplication, that 17 that's attached to our x by doing division. Let's take a look at it. The opposite of multiplication is division. So let's take a look at the example that they gave us here. Okay, slide number 12. It says step number 1 to solve this is use the inverse operation to get the variable by itself. To undo multiplication by 3, we have to divide by 3. So let me just ask a question before we even look at this over here. Don't even look at that. I want you looking at the Zoom screen. When we look at this piece right here, when I have a 3x, there's no symbol in between here telling me what operation is going on. So what operation do we know is going on then? If there's no symbol there telling us, what operation can we say is going on? Nice job, Bridget. Nice job, Kaylee B. Nice job, Jaden. Nice job, Gabby. Nice job, Avery. Yes, when there's no symbol here, that means the same thing as multiply, right? Or times. So 3 times x. So to undo that 3 times x, because the opposite of multiplication is division, we would divide by 3, divide by 3. Dividing by 3 cancels out the 3 in front of the x. Okay, so when you have a number attached to a letter like this, we need to remember that it's multiplication that is attaching those two things together. When we divide each side by 3, we're going to cancel out these 3's. The 3's cancel out. We're left with our x is equal to 12 divided by 3, which is 4. We plug it in. Plug 4 in for x in the original equation. 3 times 4 equals 12. So that means 4 is the correct answer. So if you were to take this and you take the original equation of 3 times x is equal to 12, we can plug, oh, Mr. Rain wrote the wrong thing. Give me a second. We plug in that 4 for x. We would say 3 times 4 is equal to 12. And we know that that is correct. 12 is equal to 12. 3 times 4 is equal to 12. So this is a correct answer. Nice job, Avery. Okay, last one we're going to look at is slide number 13, is looking at division. I have this equation right here. X divided by 2 is equal to 5. What is the inverse operation that's going to undo that divide by 5? Let me know in the chat. What operation is going to undo this divide by 5 on the left side here? Nice job, Avery, Jaden, Kaylee B. Awesome job. Lay. Nice job, girl. It's gonna be multiplication. Very good. So if you were to come into this box right here, you would say, what is the operation that's gonna go on here? It's gonna be multiplication. Boom. Multiplication. And let me click here. One second, guys. Yeah. So let me sort of precursor this, but very good. Nice job, Avery. Woo! So we would multiply each side by 2. And this is where it's going to get a little bit hinky. Okay. So let's slip and slide down to slide number 14, where we're going to look at how we're going to write this. Okay. So we're going to use step 1 is always use the inverse operation to get the variable by itself. To undo dividing by 2, we need to multiply both sides 2. Okay, you can undo division by multiplying, making sure that you're multiplying both sides by the same number. So to cancel this guy out, this divide by 2, we need to multiply by 2 on the left side. If I multiply by 2 on the left side, I need to do the same thing to the right side. So we would be left with, this cancels out this fraction piece here, and we're left with just our x is equal to 5 times 2, which we know is 10. Okay, because the opposite of division is multiplication. Okay, and then if we check our work, we're going to take our answer and plug it in for x in the original equation. Does 10 divided by 2 equal 5? Think about it, guys. Does 10 divided by 2 equal 5? Let me know in the chat. What do we think? Yes, Avery. Yes, Kaylee B. Nice job, Jaden, Bridget, Kaylee, Lily. Very good. I'm getting a lot of things from people. Nice job. Billy, how we doing out there? I haven't heard much from you today. Let me know how you're doing. What do we think? Okay. Oh, yes, nice job, Leah. Woo! Yes, girl. I'm so proud that you're being an active participant today. Nice job. Perfect. Awesome. Question. This is sort of a weird out there question. Was Sawyer here this morning? Do we know? Okay, so he was, but he's not here now. Okay, interesting. What about Courtney? You know anything about Courtney? Maybe? Okay. Anyways, that was sort of just a random little thing. So the last question, the last thing that we're gonna do, oh, you haven't heard. Okay, perfect. Okay. I mean, we're basically done, Kyle. So it's okay. You can have him come in, but I can, because I'm gonna go through the afternoon work, but yeah. So let's take a look at, I'm going to sum up what we did for today, and then I'm going to show you what you're doing for the afternoon work, okay? So when you're solving equations, you need to get the variable or the letter by itself. That is your goal. When it tells you to solve an equation, you need to get the letter by itself. And the way that you do that is by using the inverse operation to cancel out any of these pieces. Oh, sorry, Sawyer. I guess I let you in and I didn't mark you down. Thank you. I trust you, Sawyer. Perfect. Fantastic. I just didn't mark you down. It's one of those days, Sawyer. Okay. Okay. So, to do this, you use the inverse operation to cancel out any of these pieces that are attached, either through multiplication, addition, or subtraction. Okay. Then you also, whatever you do to one side, you must do to the other side. So it's just like a scale. Whatever you do, you want to keep it balanced. So if you add 5 to one side, you have to add 5 to the other side. Okay. So the inverse of addition is subtraction. The inverse of subtraction is addition. If you have multiplication, you have to do division to cancel it out. If you have division, you have to do multiplication to cancel it out. Okay. And last thing that I'm not gonna go through I'm not going to go through these here because we do a bunch of them in the video. So what I'm going to sort of show you to close off for today is our afternoon work is, you can use the links on the bottom here, but everything is also available through Classroom as well. So if you go into Classroom, okay, so if you come into the Classroom and you go to the Classwork tab, you're going to see an assignment that looks like, give it 1 second to load. You're going to see an assignment that looks like 1/04 afternoon work. Everything that you need for the afternoon is linked in there. So you can, in theory, turn the slideshow in for today because everything you need is going to be attached in this, this right here. Okay, so when you come into the assignment here for the afternoon, let's just let the directions load. Okay, you're going to have two things that are attached here. You have a Desmos link and you have an Edpuzzle link. So you have to complete this Desmos activity using this Edpuzzle video as a sort of guiding post for you. I go through everything that you need to do. I read through all the questions. I give you work time. I go through most of the answers. So what you're going to do is you're going to open up your Desmos activity. I would maybe keep it in one tab, pull it over to half your screen, open up the Edpuzzle in a new window, pull it over to the other half of your screen. When you click on the Desmos link, it's probably going to have you log in through Google. So you're going to want to log in through your Google account, your school Google account. Your name is going to be here. Please don't change it so that I can give you credit for your work. So you're going to come in, your name's going to be here. You're going to log in through Google, your name's going to be, and you're going to get started. Okay. I'm going to close it out so it doesn't open it for myself. So you can turn the slideshow in You can turn it in now if you'd like, because you don't have to do anything on that slideshow. Everything is linked in here. You might want to, if you forgot some of those ideas of inverse or anything that we talked about today, you might want to pull it back up later though, okay? But you can turn it in now so that you don't forget to do that if you want to, because everything you need is here. Does anyone have any questions for what you're doing this afternoon? Okay, so I am available. Oh, give me 1 second, Diego. Okay, so listen, so give me 1 second. Yes, so Mr. Ray just got confused. I am available this afternoon for extra help. All afternoon except for from 1 to 1:30. So if you have questions, shoot me emails and we can set up a time to chat if you need to. That is that. If you have any questions for me, you can stay in. Diego, if you want to stay in, I have a very good answer for you. And if not, I will see you all tomorrow. Have a fantastic day. It was so great to see everybody. I will see you all tomorrow. Bye, guys.
Bye, Mr. Main.
Bye. Bye, guys.
Bye. Have a good rest of your day.
Bye, Keely B. Okay, so Diego, let me just close the participant list so I can
Okay.
see the whole thing. So let me I'm gonna stop the recording. I just want to stop the recording.